Hello and welcome back to the Troutman Pepper Battery and Storage Podcast. I am your host, Bill Derasmo, and with me today is Alex Livingston, the president of Joule Case, Joule Case. Welcome to the program, Alex.
Bill, great to be here. Thanks for connecting up with us. Happy to talk about batteries and storage.
That's the name of the game here on this podcast, so happy to have you on. So, Alex, you are from Idaho, I see, University of Idaho, Boise State. I believe that's where you work out of in your company. So tell me a little bit just about your background, how you got started in this space, and what your sort of career journey is, and how you landed at Joule Case.
Absolutely. An interesting journey. And Idaho, as you're well aware, potatoes famously, if you take a huge number of them, could make a very tiny battery. But we were not making potato batteries here. Actually, so Joule Case is my second battery startup company, both times with my co-founder, James Wagner. We both met at the University of Idaho in the mechanical engineering program and just had an interest post-grad in electric vehicles. And that started really our journey with an article in Wired magazine talking about this fancy new startup company called Tesla Motors, founded by a gentleman named Martin Eberhard. And the article was fantastic. Here's this great looking electric car. It doesn't have to be weird looking. It's built on a rolling frame from Lotus. It goes 0 to 60 faster than half of Porsche's lineup at the time. It really was not out of this world expensive. So we're thinking, oh, this is very exciting. Okay, this is really a big change in fundamental technology and how transportation would work. You go online and all of the comments were, I can't drive this from my one house in San Francisco to my other house in LA. And if that doesn't sound like a problem that you and I have, it's because I don't have any homes in California or otherwise. And so that didn't really feel like a realistic problem. And it set us off on a journey of trying to look at energy and the way that we consume it in a different way. And at the time, those issues with that vehicle were recharge time and range. And so we started a first company called R2EV, Removable Rechargeable Electric Vehicle. And that was in 2007. It took us a couple years. We built some prototypes. We continued to eat ramen as if we were in college with revenues off of our first job. So we just kept that going for a little bit and started making prototypes, building different rapport in the industry. And we ended up with a contract with Tier 1 auto integrator over in Spain. They had a contract with the Spanish government to build and assemble 12,000 electric taxis, with the one clause in there that it needed to be with a modular removable battery system. Now, you could think back at the time, 2008, 9, 10, there was another company called Better Place. Better Place did not have a modular battery platform. They had a singular removable battery, and it ends up that the battery overextended from the vehicle platform they were using by a few inches, which is non-ideal if you're thinking about a battery structure not fitting into a car. Well, they weren't willing to change their design for this application. And we said, well, we're modular with these little blades, and you can rack them into a Fiat Panda. Not an attractive vehicle, but generally pretty good at being a taxi. Ended up with this contract, started working with the auto integrator. And then, as we know the story, in 2010, austerity measures in Europe, that actually voided the contract with the government. And so we thought, okay, well, we'll come back to it at a time that energy may be more interesting. We need costs to come down on lithium batteries. Well, they did. We re-reviewed what we were doing and thought, let's start a company again. What would we change? Well, with R2EV, those batteries all had to rack into a specific predefined bus. And so that could all be a parallel bus at 48 volts or a series bus. And so you could increase your voltage to drive your vehicle, multiples of those to add range. But we thought, we can't do that. We can't have a predefined bus all the time. This needs to be an energy platform and a framework. And we integrated that bus system and started filing for IP. And so we have a stackable battery platform. We started that very early on, started filing for IP in 2015 in research and development mode. Basically, just trying to come up with a concept of how can we turn a battery into a fuel source. And it needs to be functional and ubiquitous and can do all sorts of things. And here we are doing that today from small scale to large.
And so when you say it's a stackable battery system, that I'm just reading from your profile, it's a stackable battery system that allows the customer to create the perfect solution for their power problem. So are you mainly in the mobility space or the stationary storage? What sphere do you see Joule Case playing in, or both?
Actually, the way we like to look at it is digital fuel, coined here first, right? So digital fuel is how we look at this approach overall. And whether it's a high octane fuel source to run a jet engine, or it's 89 octane to run your weed whacker or your old Toyota, there's a fuel platform that we all know and understand in the combustible market. And we're trying to create the same experience with electric applications, whether it is powering a generator replacement, whether it is in mobility, or whether it is in more advanced use cases where we're able to store this energy and use it in really interesting ways. But it's always a fuel source. And if we treat it that way, we can do really interesting things with it. And it helps people to kind of conceptualize what it is that we're doing. It is a storage platform as a fuel. And if we can help them with that, that's what we're trying to accomplish.
Storage platform. And what is your battery chemistry?
So it goes to battery chemistry and say, well, all right, if you have different cells, they all run at different voltages. And how many of those do you have in series? And then you make a pack and you make a module. Are you putting more modules together to get to this? And that becomes a really tricky thing to try to understand and to try to manage. So if you think about jump starting your car, it's 12 volts and we have a very small voltage difference. Even just that voltage difference creates a pretty big spark. And obviously it's the current and the amount of power and the energy discrepancy, but just that voltage difference alone can be a problem. And so we've designed a system that we match voltages across different platforms. So chemistry is really agnostic to us. And we do this today. We use NCM, we use LFP, and we're studying the application of sodium for a variety of our different technologies where we don't need as great a mobility, but having these portable systems is probably key to scaling. And so we're able to use any technology that's out there, and we match this with DC-DC converters to create that digital fuel.
Digital fuel. I think that's going to be a new phrase for the audience. So maybe dive into that. What exactly do you mean by digital fuel? Because it's a new term for me as well. And I think this is about my 36th podcast episode in this space. So the first time I've heard someone use that, maybe you could elaborate.
Well, it's great that it's new because we think we've invented it. So it's great that this is a new experience. But really, it's that concept of if you have a 48 volt platform, now you're stuck into a 48 volt platform. Once you go into higher voltage, there's a huge range of voltages that you could expect to encounter, whether you're trying to power an inverter, receive power from a charge controller, drive a vehicle, charge a vehicle, or whatever it is that you may encounter, coupling additional batteries together. You need to have a fundamental commonality. What we've coalesced around is to describe this as a digital fuel. So intelligently, we establish communications between a DC-DC bidirectional network, and we can now pass power across that entire network. So picture a battery system that maybe its native voltage is around 700 volts for its pack, but we have an inverter that would prefer to operate at 900 volts. And we have another battery system that its battery voltage is maybe 1200. By using these DC-DC converters, we can match to a common fuel framework and move that energy as if it's all the same thing. And that's what we're trying to accomplish, is to make that seamless and easy for you. You just need to know that there's some energy that you have, and you need it to do something else for you.
Okay, interesting. Okay, so let's go into my world a little bit more. We've talked a lot about the mobility space from time to time in this program, but I think anyone who's listened a lot knows that my heart is closer to the stationary space and the grid scale space. So how could Joule Case work with a stationary application, a grid scale application?
Well, we have a number of grid scale applications that we have out in the market today. And these are facilities backup where we're doing the common typical thing. It's peak load shaving, demand response applications. But now we're working with groups where when they're installing a large piece of equipment into manufacturing, we actually provide a buffer for that specific piece of equipment. And these are harmonics issues that may come about when they're trying to couple up a large dryer or ozone machine in water treatment. They now have to sign a number of agreements with that manufacturing partner when they go and install this piece of equipment to say everything that we connect up to, all to the common point of connection before it goes back to mains, we guarantee that there won't be a problem there. Now, it's difficult to guarantee that when you have big electric systems that come online, being able to ensure that you're not having harmonics and frequency issues. We're seeing this a lot with charging going on across. Did you do proper balancing through the phases throughout your parking lot? Are they all coming in on time? So we can do a lot of load shaving and management of those harmonics through a stationary system. Again, by using this DC-DC platform, we can remove a lot of that.
I would imagine it would be important with data centers.
Hugely. And this is one of the things with AI right now that it is creating kind of an unknown for grid operators. And one of these big boogeymen in the room is Do we need to double, triple, quintuple our grid capacity to match some of the power applications that we're seeing with transportation electrification and home heating electrification? But data centers are a big unknown. We do see quite a bit of that, but these data centers haven't moved too quickly away from just that fast transition and immediate peak load shaving. And so there's, in many cases, they're still using lead acid.
Well, interesting. I mean, I think you ran through a lot there, and I'm just curious because I think it brings together a lot of things. So I think what a lot of what you're talking about, it would implicate the amount of capacity that we need on the system overall. And I think what you're saying, maybe I'm mistaken, is we may not need as much capacity as people think if we use some of the technologically advanced devices such as what your company has developed. It's maybe I didn't say that all that great, but I wanted to get your thoughts on that point.
Bill, I think you nailed it. And the way that we look at this is we already have the production, the transmission for our peak loads. Let's look at how we're actually using that energy. And if we can, it's not just as simple as put a battery somewhere and it will manage itself. But if we look at where these applications are, we look at the different businesses, NACIS classifications for those businesses, we can look at their power profiles, and we can find capacity overflow. And if we can grab that capacity, it's now a bandwidth issue. And it's bandwidth at the time that you need it, and being able to have energy storage to solve some of those needs. Maybe, and this is what we believe, we will not need to increase capacity in terms of transmission or in terms of production on demand. But if you're a utility operator right now and someone says, in the next 20 years, there will be 380 million new electrical devices, the kind of which you've never seen before, demanding huge amounts of power for you, you say, the only way I have to solve this is to add more production, more transmission, because I know you're going to want your power right on demand, and we can't produce it in the other.
Right. I mean that's the big elephant in the room, right? Within the electric industry, electric utility industry, and among the system operators is that we keep retiring dispatchable resources for various policy reasons, right? And carbon reduction, et cetera. So you have all that. I mean, to begin with, the inertial response goes because then you have trouble with the ancillary services and voltage, et cetera. But then you just have capacity issues and quick start resources when you have a severe winter storm or some other kind of event. When you retire the coal and the natural gas, it becomes a problem. So I think what you're saying, though, is that you can play a role here in getting more out of the existing resources on the system, but just using them in a more smart way or a more efficient way, I should say.
Yeah, smart and efficiency. If technology is not making your life easier and it's not improving what we already have, it's the wrong thing. And technology probably isn't the word for it. But in this case, if we look at a couple of quick numbers, in the US, total consumption, and this is paid for consumption, what we're able to gather in terms of data is 4,200-ish billion kilowatt hours. And why do I put it in kilowatt hours? Because that's a number that we're used to thinking about. But then when you make it 4,000 billion, so I could say, 4.2 trillion, but then that starts to get sort of unimaginable. But this seems like a huge amount of consumption.
What about terawatt hours, right?
You're right. It turns into terawatt hours. And that's really a hard number to start to get your head around. And so we can start to break that down a few ways, and we can look at, okay, well, if it's in hours, how many consumable hours do we have across a year? Well, there's 8,760 hours consumable in that year. And then we can start to break things down a little bit further from there. But let's also look at what our total production and transmission capabilities are in the US. Well, that's 14 billion kilowatt hours if we multiply it out to that time. So we have an extra ability in a year to create another 10,000 billion kilowatt hours. And so that's more than double what we're needing right now. Say, okay, all right, well, if we know we've consumed this 4 terawatt hours and we can make 14, what can we do with that extra 10? Can we make it less expensive and transmit that? Well, we think that's where the duck curve is. We think we can bring in more renewables during the day. As it turns out, that's typically when a trough is. So let's utilize that capacity. Say, well, energy storage is very expensive. It's probably more expensive to use energy storage as that medium than to just increase our total production. Well, it turns out it might not be when we're looking at bringing up these additional transmission and production capabilities in the terms of trillions of dollars, right? That was something that was approved in a bipartisan legislation. Was it $3.4 trillion that was approved?
I'm not sure, to be honest.
Huge amounts of money to be able to improve our aging infrastructure. Now, there will be things that we naturally have to upgrade, but we don't necessarily need to triple or quintuple that power production if we look at it this way. And then you say, okay, well, maybe we need to understand what the full impact of these electric vehicles could be. And so again, we go back and we think, all right, well, 280 million highway vehicles in the US, not including off-road, not including neighborhood electric or neighborhood, but 280 million of those, if they all have about 100 kilowatt hour battery, just for simplicity's sake, that's 28 billion kilowatt hours. And that's the thing that shocks grid operators. Is that number? Seems like we do need to increase 5x to meet those demands. But that's assuming those vehicles are running constantly all the time and they're never stopping and they will need to recharge completely all the time. And we know that they don't do that. Another way to chop that down is how many miles did those highway vehicles drive in a year? Well, that's 3.2 trillion miles driven. And then if you start to say, well, we know how efficient electric vehicles can be for those miles, we start to get to a point where we can really understand that. And if all of those vehicles in the fleet were sedans, efficient Tesla vehicles, that's only about 12 million kilowatt hours. And that's 1/1000th of what we're looking at and having an overage. Now this number seems not quite so scary.
So what about, have you gotten involved with sort of two-way charging? Because I'm thinking about all the electric vehicles and the possibilities there. And so I was wondering if you could speak on that.
V to X in general is how fleets and and transmission is looking at this now. It's not just vehicle to home, vehicle to building, vehicle to vehicle, but V to X. And when we're describing that, there's a great opportunity, I think, it's behind the meter. And if we don't push that out, but as long as we can communicate that to the grid operator, that's a very effective way of doing these things. But having all of these grid tie capable inverters is going to overbloat a vehicle system, in my opinion. And if we're able to do things on a DC-DC way, well, we can just take that battery energy directly and we can multiply it out across a number of these, and we don't have to have the extra cumbersome burden of AC transmission. But that, being a DC guy, I really prefer that.
Interesting. So yeah, let's talk about that because we kind of breezed over it. I didn't really drill into the DC to DC converter issue and talk about how that distinguishes your company from some other models that are out there.
Right. So by the time we get to the point where we're moving lots of power, we do it with DC. And this is all non-transmission related, but if we need to move a lot of power a short distance, we do it with direct current. We do that with vehicles when we fast charge them. There are only a few auto and heavy duty vehicle manufacturers that use AC. BYD is one of those, but they're already starting to make some moves where they're doing direct DC fast charging. Knowing and seeing and understanding what the voltage characteristics and behavior of a large battery system are, well, a DC-DC converter can just pull that energy out. We don't need to take it, put it into an inverter, bring it up to a grid tie capability, match that frequency, match those harmonics, make sure we're putting it in the right node. We can just pull it out and use it later. So there's a lot of advantages when we look at those type of applications. And one of the main reasons why we design that system is we can pick a much higher voltage than an operating voltage of, say, 480. So with being a low voltage transmission of 483 phase with 5 conductors, if I move my DC-DC converters up to, say, 1200 with 2 conductors, I can move a lot more power with just the 2 conductors than 5 at 483 phase for the same amount of current. And I don't have to worry about matching frequency. It's just exactly what the voltage is. So there's a huge number of advantages that can be met as long as we have the ability to pick the flavor of fuel output.
Interesting. Well, I'm glad you walked through that because I had not encountered in my travels on this program the DC to DC converter. So I appreciate that. I appreciate what you're saying about the strength of DC and its advantages in the applications I think you're talking about. Let's shift gears for a second. Let's talk about your company, Joule Case. Fairly early stage, it seems like. I was going to ask you just your experience in terms of raising equity, raising money, what that experience has been like. Because obviously you're someone who likes to get under the hood, so to speak, and build these systems. But just talk to me for a minute about the business side of things and how that process has been for you in your experience.
Well, we are a team of engineers that as a founding group, and that can create some struggles. We were able very early on to bring in some capital, and from our professional careers, James and I were able to bootstrap the company in early days, get to product and start running. We actually had orders that pretty much facilitated our whole first batch run with Joule Case. So we were able to get going. We had right product market fit, and we could get out there and describe this. We were still early days though in the consumer adoption of advanced battery systems to replace, say, a generator asset. It was fairly pricey when we first launched, and so we found a lot of market application with event production companies. So now we're starting to move further and further away from where somebody is comfortable saying, I know and I understand this business. So we weren't quite consumer electronics. We fit into this other ancillary bucket of consumer related electronics, but in a very niche field. A lot of venture capital didn't understand that at the time. We were out raising funds through angel networks. That was a good process overall. We received a lot of help, great advisors, getting things up and running. We went through the typical route and typically got a little bit more money than what we were asking for every time. If it's there, go ahead and get it, bring it in. Don't too dramatically oversubscribe and dilute. We've done a very good job of that. And then when it came time for our formal registered round, it was right before COVID. And that sort of decimated our opportunity to raise a formal round at that time. Not being in the Valley or any of the other major tech hubs on either coasts sort of hampered our ability to do that. But we found a great champion platform within some of these crowd equity facilities. And so that is a registered round. It was a very interesting way to go about things. I do think there will be a lot of evolution in crowd equity capital raising, but we had a great experience with it. A number of those investors have reached out to us and said, hey, could I introduce you to my old colleagues at fill in the blank? I think this would be a natural fit. And some of those are now our largest contract opportunities have come from that investor network, which is what you want out of having an investor, and a big investor is to introduce them to your network.
Yeah, and I see you use WeFunder, and I'm familiar with Smart Engine, and I think there is going to be more and more money raised that way, and you can raise millions of dollars through that network, and it's just a different way of doing it. And now you got individual shareholders, but as you say, they become part of your network. I will confess that I've invested a little bit of money through those vehicles too, and it's an exciting thing for individual investors, but. Yeah, I was just curious about that. It must have been an interesting experience, and I saw that in the company profile, and I think it's exciting for you guys. And of course, you've got your stake in it because you're one of the founders. And so, I always like if you listen to past programs, I always like to ask founders of these various companies what that's like. I know that it can be probably a little nerve wracking, but it's also very exciting. So I just wanted to get those thoughts on the program because I think it's a unique part of the story. So.
We've had an excellent time with WeFunder and those investors. Our investors overall in general have been excellent for us. You hear a lot of horror stories from other groups about having one particular or a couple that really sour you on things. And we've had an excellent group of investors and advisors that have worked with us. One thing that's been very crucial and core to us is every single employee of Joule Case does get equity into the company. And we wanted to make sure that people really own literally the process of being involved in clean energy and have a stake in it and get rewarded for those activities.
Well, the most sophisticated private equity firms in the world believe in that, right? Like KKR or some of these other big outfits. They like to see management and employees who own the company that they're going to get involved with because they see that that's the best way to align incentives, right? Is if you give people stakes, give people some skin in the game. So it's a tried and true way of doing it for sure. So for Joule Case, just talk to me a little bit about who's your core audience for this program, for who do you want to talk to about buying your product?
I think the best application that we have right now, and it's because of our mobility, is if today, in any way, shape, or form, you or your business or some other portion of your business relies on temporary power for any application, whether that's bringing temporary power into your building, you're going out into the world and you're relying on temporary power, very commonly a combustion fuel source, construction, music festivals, things like this, you no longer have to rely on diesel. And we've shown this over and over and over again for years that we're a much more efficient system to operate on battery. You don't have the noise, you don't have the emissions. And there are a huge number of things that we can solve that aren't even a part of the normal train of thought. For example, stringing all of the cables for miles and miles at a music festival because you can't put a generator right next to where people are trying to breathe. you now don't have to hide it. You can put that power device right up next to the stage. It reduces cabling costs, things like this. And so we're very, very good at replacing temporary power. That's right there. If we could talk to everybody that has a temporary power need, this is going from our work truck, food truck, so smaller businesses that are relying on temporary power for their daily operation, on up to mining or water pumping, things like this. So we're very, very efficient at that with the systems that we've designed. But then it's thinking about the next wave of what's going on with electrification. And what I would encourage either fleet operators, business owners, at-home consumers that are thinking about bringing electric vehicles into their lives, there isn't a lot of reason to go out and buy a charger, pay for infrastructure, go through the permitting process, trenching, laying all that copper. If you just have a battery system and you're trickle charging it and it has a DC-DC component on it, you can fast charge that vehicle and you don't need the extra component of having a fast charger. It's with our system, it's built in. And so you basically get it for free. And we're beating chargers that are being installed in the ground. You don't have to worry about service capacity upgrades, and we're a lot less expensive.
All right. Well, I appreciate you walking through that. And I think the audience will hopefully appreciate it, start getting the wheels turning. It sounds like there's a lot of applications potentially. So I really appreciate it. This has been a unique program. I think for us, we talked to a lot of different parts of the industry that touch energy storage. We've done past programs that have hit on mobility, grid scale storage, second life batteries, et cetera. But I think Joule Case has been, and Alex, you've had your unique story to tell. And so I appreciate you being on the program today. Appreciate you taking the time. I'll give you the last word. Tell the audience what they need to know in terms of getting in touch with you or getting in touch with Joule Case.
I'm available on LinkedIn. I, apart from having my new Santa Claus beard, do look like the guy that's on the profile. I am very inquisitive. I'm happy to hear from you and your applications concerning future energy needs. Our whole team is available. We design, manufacture, and we build in the United States. We have our small volume manufacturing out of Boise, Idaho, where I'm from. And then we're building up right now 2 manufacturing facilities in California and one in Texas for our larger Olympus class of products. And those are going to solve your transmission power needs.
Well, we didn't even get into that. I didn't realize that you've got 3 manufacturing facilities, and that's exciting stuff. And we might have to have you on again to talk about the second half, which would be the manufacturing facilities and, as you say, the Olympus class products, because now we're getting into transmission, and that's now speaking my sort of FERC jurisdictional language, where I'm sitting in the DC area here. We might have to do part 2, Alex. We didn't dive into any of that, unfortunately.
Bill, if you're up in the DC area, one of our new partners, Xylem, has their reservoir headquarters right next in the Navy Yard district. So maybe we'll have an off-site meeting for this next podcast.
Well, if it's by the Navy Yard, we're heading into baseball season. I love baseball. So we could go over to Nats Park, we could have a beer, and we could talk batteries, and you could tell me about your Olympus class products.
That sounds like a deal. Bill, thank you so much. Thank you, listeners. Appreciate it.
Thank you.
Copyright Troutman Pepper Hamilton Sanders, LLP. These recorded materials are designed for educational purposes only. This podcast is not legal advice and does not create an attorney-client relationship. The views and opinions expressed in this podcast are solely those of the individual participants. Troutman Pepper does not make any representations or warranties, express or implied, regarding the contents of this podcast. Information on previous case results does not guarantee a similar future result. Users of this podcast may save and use the podcast only for personal or other non-commercial educational purposes. No other use, including, without limitation, reproduction, retransmission, or editing of this podcast may be made without the prior written permission of Troutman Pepper. If you have any questions, please contact us at troutman.com.